Okay, students, transformer. What is a transformer, students? It is an electrical device used to change a given alternating EMF into a larger or smaller alternating EMF, right? What is the principle? The same as the principle. Like we have some primary coil, mutual inductance. What is the principle, students? Mutual induction that we have studied yesterday, right? So we have this primary coil, we have this secondary coil, and we have these number of turns of the primary and secondary coil, and we have these currents in the secondary and primary coil, and we have this voltage in the secondary and primary coil, right, students? And this is the result that the voltages are directly proportional to the number of turns, right, students? And here is the symbol of the transformer, this, right? Okay. So what's the formula? We just know about it, that voltage of the secondary over voltage of the primary is equal to the number of turns of the secondary divided by the number of turns of the primary. Right, students? Now, ideal machines don't exist, but if we talk about ideal machine, it would be a machine which has 100% efficiency. And what is meant by efficiency? We know that since efficiency is power output over power input. Now, what's the power output of the transformer? Since the power output of the transformer will be secondary voltage into secondary current, and the power input of the transformer will be primary voltage into primary current, right? So the efficiency of the transformer will be looking like this: VSIS over VPIP. And if, students, these two powers are same, if power input is equal to power output, then, students, the transformer is ideal. Like VSIS becomes equal to the VPIP. Right, students? Then we're going to take the ratio of this thing. So it will be like Vs over Vp is equal to Ip over Is. And what does it show us? It shows that, students, the voltages are inversely proportional to the currents, right? Okay. So now types of transformers. Students, first type of transformer is basically step up transformer, right, students? What is happening here? The secondary number of turns are more in number than the primary number of turns, right, students? So, secondary number of turns are more than the primary number of turns. So the voltage of the secondary is also more than the voltage of the primary, because the voltage is directly proportional to the number of turns. So this is what we call as the step down transformer. Sorry, step up transformer. And, students, what about the other one, students? That is called step down transformer. It is definitely going to operate in reverse. Like if this is like number of turns in the primary, and this is like number of turns in the secondary. So the number of turns secondary is less than or fewer than primary. So voltage of the secondary would also be less than the voltage of the primary. So, students, we call it like step down transformer. Okay, losses in transformer. There are two types of energy losses in transformer, students. The first type is copper loss or resistive loss, or we also call it like hysteresis loss, right? Okay, students. So let's talk about it. Okay, the power loss in a transformer because of the resistance of the conducting primary and secondary coils. This type of loss occurs in both primary and secondary coils. And we have studied this chapter, students, that the power loss is looking like this. We studied this thing in the chapter materials, remember? Okay. So this was the magnetization curve, and let me remind you, okay, what were the things called here? Since this was called saturation, point A, and students, this was called what? Retentivity, and this was called what? Coercivity. If you remember, if you don't remember it, then you need to like revise that lecture. What was this, students? This was negative saturation. And students, this was called like negative retentivity. And this was like coercivity in opposite direction. So this basically, I told you students, okay, the area of this curve represents the energy loss, like this area that I'm going to shade. Students, this is representing what? This is representing what? The energy loss. The energy loss. Right? Okay, this is the same energy loss that we studied over there. What do we call it, students? This area is called hysteresis loss, and this loop is called hysteresis loop, right? Okay. Now, students, next type of energy loss in a transformer is this eddy current loss. Changing the magnetic flux also links with the iron core material and reduces current in the, and we call it eddy current. And power loss due to eddy current is called eddy current loss. How do we like reduce it? To reduce it, students, we use reduce the surface area of the eddy current, and it can be further like decreased by using a core made of thin insulated strips instead of solid insulated iron core. Like students, this ये तो पहली बात होगी ना कि हमने इसे इंसुलेशन कर दिया यहाँ पर. अभी एडी करंट यहाँ पर स्टूडेंट्स फ्लो कर रहा है काफी ज्यादा एरिया, लेकिन इफ वी यूज लाइक स्ट्रिप्ड, this is like stripped iron core, stripped insulated iron core, तो फिर इसमें there will be like less eddy current loss. ठीक है स्टूडेंट्स, ये सॉलिड आयरन कोर में ये देखें एडी करंट कितना ज्यादा हो रहा है, और जो लेमिनेटेड स्ट्रिप्ड आयरन कोर है जिसमें स्ट्रिप्स यूज हुई हैं, तो उसमें स्टूडेंट्स एडी करंट का एरिया बहुत कम हो जाएगा, तो फिर ये लॉस भी कम हो जाएगा. ठीक है स्टूडेंट्स, तो ये बच्चों आज हमारा चैप्टर तो फिनिश हो गया. अब जरा लेट मी सी कि